Right, so let's have a look at this lab. So what we're going to do is we're going to do some Snort analysis of fairly complex traces and see if we can actually detect the activity. We'll also be using Wireshark to be extracting the artifacts from the trace and looking at net witness, and then we'll look at some evidence bags and see if we can pick off the file types. Okay, so the first thing we're going to do is we're going to download this file here. And then we're going to use Snort offline to be able to analyze it. Okay, so let's open it up. Okay, so I've set up a simple rules file here. Okay, it has a few things that it needs to be able to set up the trace. So I'm just going to extract it into our folder that we've set up. So I think I've put it into snort/bin. And there we are. Okay, so we should have our new trace in here. And there it's there. Fairly big trace. So what we want to do is to be able to analyze that in terms of its contents. So if we have a little look, so you should find there's lots of activity there, and it's obviously extremely difficult for us to make much sense of that. So we can see there's something like an Nmap scan there. Lots of other types of things. So we might have a large trace that we need to look at. So, okay, there's another Nmap there, and there looks to be an ARP scan in there. I just saw an ARP scan. Remember what we do was we can use the filters to be able to find things, but we'll try and use Snort in this case to be able to identify the activity. So we can see here there's a standard sign of an ARP scan, okay, across the whole network. So the node that is doing this is at 192.168.0.12. Okay, so let's go and do this. So the first thing we'll do is we'll look at the bad logins for FTP. So we'll just open up our trace here, and then we'll just grab our rule for bad logins, which is this one here. And I'm just going to paste that into there. Okay, so this is the message that's coming back from the FTP server. Okay, so it's from port 21, so it's coming back from the FTP server to there. Okay, so we'll just save that. And we'll just see if it's all set up. That looks fine. So we normally save to the log folder, and one of these I'll just erase all of that so there's nothing left in there. And if you don't have a log folder, make sure you create your log folder with make directory log. So now what we'll do is we'll use snort -c, our rules file, and then our -l for the log folder, -r for the trace. And there we are. Okay, it doesn't take too long to go through it. So we have 41 bad logins there. Incorrect logins for FTP. We can actually have a look at those, and there they are. Okay, a whole lot of bad logins there. We can see they're typically coming from one machine here. This is the server, and this is the client here. So it looks like this is some sort of Hydra attack here. And then what we'll do is we'll have a look at the number of successful logins. So as you remember, that was 230. It's got a good login there. And then we'll just run that again. So we'll just get rid of that. We should be good to go. Okay, so this time there's 11. So there's 11 good logins there. Okay, so there's our good logins. Actually happened from this machine here. So there was some successful logins. So now let's look at the number of GIF files that we have within the trace. Okay, so we're typically looking for our magic numbers. So this is one here. And we'll just grab each of these. It's not pasted in very well, but it should be fine. Okay, so we want PNG, and we want GIF in this case. So let's not do that there. Okay, so there's the standard magic number for a GIF, and then there's the one for a PNG. Okay, 89, 50, hex, 40, 47 is PNG. Okay, so let's go with that one. So this time it's picked off 456. Okay, so there we go. There's all our GIF files there. It's detected them successfully from that. Okay. So now what we want to do is to detect a port scan to see if we get a port scan from there. Okay, so we'll just look at our rules. So here's our rules for a port scan. We use a preprocessor called FS port scan, and we'll save it into a file called portscan.log. So if we put a slash at the end of a line in Snort, it means that it continues to the next line. Okay, so we'll just do that like that, and then that should be good to go. Preprocessor, that's everything fine, and it's going to store it to that log file there. I'll just save that one, and then we'll pull up our thing there. Okay, it's got a little error in it. FS port scan, sense level, and then log file. let's just check. So the proto is all for that one. So everything's fine there. Just make sure we get some spaces in there. Okay, so we've got some spaces in, so I think we should be okay now. Good to go. Okay, that's much better. Okay, so it didn't manage to pick up a port scan there. I'll just have a look. Oh, it has. There we go. Okay, there's our port scan. And that's there. Okay, so it's picked up a UDP port scan there from .1 to .11. It's also picked up a TCP port scan from 12 to 7. There's another TCP one there. And there we go. There's a port sweep there. Then another UDP. And so on. Okay, so you can see that successfully picked up our port scan. Okay, so now let's do the second part of this lab. So what we need is our bad FTP. And it's Hydra score FTP, that's it. Okay, so let me extract that out. Okay, so I'm just going to make life easy for myself here. So I'm going to actually take the rules directly from here in a text format. Okay, so we've set up this page here, which should allow you to be able to see what the rules should actually be. So and here we are. So in this case, what I'm wanting to do is to be able to find our good and bad logins. So for FTP, so there we go. So we'll just grab that one. Okay, so that's 530, and that's okay. Okay, so this trace itself, when you have a look at it, you should be able to see there's the standard signs of a Hydra type attack. When follow a stream, we see lots of logins, lots of incorrect logins. Remember, if we look for our response code, if you remember, we are looking for 530. Okay, and for our good login, we're looking for 230. Okay, so hopefully in this case we'll only find that there is one successful login. So what I'll do is I'll just erase all of that and go back again, and just let me see how I'm doing with my rules. So that's fine. So let's go ahead and do that. Okay, so 41. That's good. And there's all those bad logins. So if we go back to Hydra and we go back to our code, hopefully we should find there are 41 bad logins there. Okay. In fact, what you can do is you can actually mark the packets and that allows you to export them all. Okay, so just let me do a save as. Oops. We can see we have 41. Okay, that's it. That works out perfectly. Okay, if I just change it to a correct login, hopefully we should only find that there is one in there. So 230 user is what we're looking for. Okay. So the next one we're going to do is to be able to detect our Telnet login. Okay, so just let's try and find our rule for Telnet. Telnet does it. There we are. Okay, so we can actually have a look to see when we get a login. So we've got the login there. That's not really going to give us any clues. So if we search on port 23 for login, that should give us the login details. Okay, so when we reply back from there, I'll just do Telnet login, and let's just go for login. It's case insensitive, and that's fine. So let's try that. Okay, so now we want Hydra for Telnet. And that's it. So there we go, we've got 23 logins there. Okay, so the next thing we're going to do is to do a port scan. So let's find our port scan one there. Okay, so there we are again. We tried that one before. Let's try again. From here. Okay, remember to put your spaces in there. And so we're going to download an Nmap scan. There we go. There's our port scan set up. Okay, so it's detected one there. So make sure that you just pull up your the scan and just check that that's actually correct. Okay, it looks like the scanning machine is this one here. So if we have a look, and there we go. Okay, so we can see here that's the scanning machine 75.1 and it's scanning 132 there. And those are the ports that it's scanned. Okay, so Snort has successfully managed to detect the scan. Obviously, if we used an alert on every single port that was a SYN was sent to, our logs would be absolutely massive. So it's good to be able to aggregate these then with Snort. Okay, so the next thing we'll do is we'll detect a SYN flood. Okay, and here we are. This is our SYN flood here. Okay, so this one detects on port 80 a denial service. It takes 60 SYNs over 60 seconds and then shows that. So we'll just make sure that we get rid of our logs. And now what we want is our H ping. Right, okay, so let's have a look at it first, just to see which port that we're dealing with. And it looks like it's port 0. So we'll just modify that. And there might not be enough SYNs there for it to be able to pick it up, but we'll give it a try. Not quite. So what I'll do is let's see if we can get one that has more than 60 in it. H ping. Let's try this one. Yeah, it's not really got a great deal in them, so there isn't really enough for us to trigger. But that's how we would actually do our detection there. let's jump on a little further. So what we'll do is that we'll have a look at detecting certain file types in our traces. Okay, so the first one we'll have a look at is the PDF one. Okay, so we'll just grab the PDF scanner. This should be one of the file type ones that we've got. Here we are. Okay, so we'll just paste that one in. That's a PNG, so there's our PDF. Remember, we need the unique SID for each one. Okay, so remember to change your SID if you add the new rules. Okay, and then we'll just download our PCAP file with pdf.zip. Can you open that up? Okay, with PDF. Have we detected it? Yes, we have. That's good. So we've got two alerts there. And there they are there. Okay, so there's both are coming from a website. This address here is the download. And what we can do is we can extract from our Wireshark trace the artifacts within that. Okay, so we just do file, and then it's export objects, and it's HTTP in this case. And there we are. Okay, so we can do a save as, and you should be able to get the PDF from there. Okay, so if you remember, we used the %PDF to be able to pick off our PDF files from our Wireshark trace. There we are there. And there is the name of the file there. Okay, so when you do an extract, you should be able to find that you can pick off this PDF. There's the PDF header that we're looking for there. Okay, so we'll try one more. We'll go for the MP3 file. That's quite interesting. Okay, so we need to find our MP3 file. So that's with MP3. To see that we're running a music site, and we want to detect whenever there's an MP3 file being transferred off our site. So let's extract that one. And there we're there. So there we go. This is the one we want. So 494433. And if you want to see what that actually is, if you go and have a look in digital forensics, look at magic numbers here, find MP3, and it's ID3. So an MP3 file has an ID3 header in it. So that's what we're actually going to be looking for, ID3. So if you look at our file, there we go, ID3. And that's the header that goes on to the MP3 file. Okay, so let's see if we can detect our MP3 file. So I'll save that one. And hopefully, we found seven places. There we go there. So there's the site, it's a website there that's coming from. So let's see if we can actually extract the MP3 file from there. Okay, so there's one there. Okay, we'll just save that one. Let's try again. Okay, so we're going to extract there, and we'll just go ahead and save them all. So it should be in Snort bin that we're actually saving it. Oh, sorry, there. Okay, so there's our MP3 file. It's quite boring. And then there is our other one. It just sounds like it's two tones. We can also have a look at the other graphics and things, and no, it's not actually shown. Okay, so that's the way that we extract our artifacts from there. So we'll do one more. We'll do a Rar file, and then we'll go on to the next part. Okay, so obviously Rar files are very important to be able to detect, because we can get large-scale data loss if these actually are taken from our sites. So it's log, and it's with rar.zip. Okay, and then we'll just extract that. Then we'll just have a look. Okay, so there's a rar there. And what we'll do is we'll just extract that first, just to have a little look. Okay, it looks like there's a file called botnet in there. There we go. There it's there. Okay. So what we'll do is we'll try and detect our Rar file on the network. Okay, if you want to see what a Rar file looks like, again, go to the magic number page and find your rar. Rar there. Can either do it with hexadecimal or, in this case, with characters. Okay, so a rar file is identified with that array R. So we could do it lower, upper and lowercase there as it is, or we'll just ignore the case and we'll detect it. So we'll just open up our file there, and let's go for something slightly different. Let's do hexadecimal this time. Okay, so that's our rar there. And let me go into the log folder and I just erase everything here. Just to make sure it's all working. Okay, should find it there. Okay, with rar. And there we are. Excellent. Detected 3 as we did in Wireshark, if you remember. And hopefully we've detected successfully that there was a rar file there. Okay, so there was the site we were contacting. I think that's actually a security site, and it's downloaded from port 80, and there's our connections there. Okay, so do the same with the zip and the GZ zip. You should find each of the magic numbers on this page here. Okay, so it's a security site forensics magic, and so there's gzip 1f and 8b08. So I'll do this last one, and so we go here. Just let me do this one last one. And it's a gzip file. We just have a little look to see what they look like. This is standard compression method using LZW compression. Used in a lot of applications. There is a little header there. Okay, this time we've got to do it in hexadecimal because it's non-printing characters. Okay, so we'll just save that one. And now we just find our gzip file. Okay, there we go. So we'll just extract that. This one's called dot with gz. And it has this detected one there. That's great. So it's detected the alert. And there we go. There's the evidence should be in here. So there's the gzip there. So it's found one example of that. And again, so it depends if we've using port 80 there. Looks like we are. So what we'll do is we'll just see if we can extract that. And there it's there. Snort bin assets 3. And there is a lovely little GZ file. And there it's there. And it just says this is a test. Okay, so if you remember, what we would do is to be able to use the magic number again for that. So our magic number in this case was 1F X 8B /08. Okay, and there we are there. Okay, so it's found it. And if you want to actually see the hex to be able to make sure that you've got zip file there, then you can actually just look at it in terms of the hex view for us to be able to find the file. Okay, so there's where it's been requested. And here is where it comes back. Okay, this is the header that is put onto it in terms of the HTTP request. But you can see actually the file. See where there's a line feed cache return there. Our magic number is here. Okay, can you see that? Okay, there's the header, and then there's the actual gzip part. And it starts there. Okay, just let's check. It starts the 1F 8B08. Excellent. Very good. Okay, so just as a last thing, let's have a look at our BitTorrent. Let's see if we could detect that. Okay, so with BitTorrent, we're looking for the BitTorrent protocol. So we can actually pick off, hopefully, from the packets, the actual communications that actually happen with BitTorrent. So it looks like it's this one here gives us our BitTorrent protocol. Okay, so see if you can find a rule that you can pick off from that. But there's obviously one. If we look for the announce word with a get in port 80, then that's a possible way that we could detect it. And there are a few other things that we could actually look to detect, such as if we look at the hex value of the exchange. Okay, so I could detect the word BitTorrent there. What we could do is, so we're looking for the handshake. So again, the word BitTorrent comes out there, so that would be quite easy to just pick that off. So actually, I'll just do that. It's probably easiest. Okay, so again, it's up to you what you want to pick off for the actual string, but I'll just use the word BitTorrent because BitTorrent appears here. BitTorrent protocol appears as a word. So we could go for bit, capital T, torrent, then there's a space, followed by a protocol. Okay, so let's see if we can detect. And we have. So we've detected 11 different messages there that involve BitTorrents. Okay, and there they are. So you can actually see the hosts that are actually involved in the BitTorrent. But obviously what we would do is we would be able to pick off each of the different elements and basically capture some sort of hex signature for them. Right, so let's have a look at NetWitness. So we'll just create a new collection here. Okay, and then from there we'll just import our packets. So I've already downloaded the first one, which is with PNG. And from this one we're going to identify all the IP addresses that were involved in the trace and the location of the hosts and the servers. Just takes a little minute to load up. Once it's there, you actually find there's a whole lot of information that we can actually see from this. Okay, so there we go. So for the first one, these are all the IP addresses that were actually involved. There's some source addresses. We've got some host names there, BBC, Napier, and so on. Okay, so there's a whole lot of things that you can actually go and drill down from there, such as the IP addresses. We can actually have a look at the content from the site that was actually involved. Okay, so for the last part of the assignment, what we've got is an evidence bag. Okay, here we go. So for this one, we're not actually telling you what the files actually are, and it's up to you to be able to find them. So I'm going to just use a standard hex editor. Okay, and then I'm just going to drag in our files. That's an easy one. That's a GIF file. Okay, so if I change that to a .gif, hopefully should be able to view that one. That's a picture of a cat. Oh, it's an animated GIF. Second one. Second one is also a GIF file. So hopefully I can change the file name there. This one is also animated GIF. Third one is D7CD. Let's see if we can find any other clues. Nope. D7CD. Okay, so if you go to the security site and then forensics magic, then just search for D7. There we go. D7CD C69B. So I think that's a Windows meta file. Or a WMF. Perfect. Okay, fourth one. It's a bit easier. FFD8 is a standard JPEG. FFD8 standard JPEG. And there we go. Okay, I'll do one more. We'll just start, it's very difficult to finish. So this also looks like a JPEG. You can see that one there. And it is, looks like a Cluedo. Okay, so you should find the magic numbers are here. So just go and have a look to see if you can actually find the magic numbers. And then there should be examples actually from them. Okay, so that's been Lab 7.